Many. Many and nomial, what do you think that is?
Numbers.
Numbers. So we're talking about many numeric parts, and that's what a polynomial has. It has many, or at least several, numeric parts.
Okay.
And you're familiar with polynomials, stuff like this. That's a polynomial. That's what we call a polynomial in X. That's just a polynomial. Now there are aspects of a polynomial that you need to be familiar with because they're going to be referred to. And when they're referred to, I need to know what they are. It's that simple. There's some terminology that goes with polynomials. First observation. This is standard form. Notice the decreasing order of exponents. Did you notice that? That's standard form. x2, x1. And by the way, what's the power of x here? 0. Think about this. X to the 0 is the same as 1. So negative 7 times 1 is negative 7. But that's typically not how we write it. But that is, by the way, x to the 0 power. So this is standard form. Notice that we can talk about the terms of a polynomial. How many terms does this guy have?
3.
Very good. So it's the parts, and they're separated by pluses and minus sign, right? Plus and minus sign. So I got these 3 parts. 3x squared is 1 part, that's another part, that's another part. It's in standard form. When it's in standard form, this is called the leading term. Okay? The first one is called the leading term, which means this 3 is called the leading, what do you think? Coefficient. Hey, the coefficient of your leading term, it's your leading coefficient. So you will be asked about a leading coefficient, so I need to know what it is. When it's in standard form, it's the first coefficient. Likewise, this last guy has a name. Anybody know what it's called? What kind of term? Constant term, absolutely. And that's a very descriptive name because it's constant. It stays the same. You know, you substitute x for anything, the other values, the other terms are going to change their value. But negative 7 stays negative 7 no matter what x is, right? It's constant. It's always negative 7. So that's just a little bit of nomenclature for you there, just a little bit of terminology that you'll be asked to recognize when they talk about a leading coefficient or a constant. All right, when we talk about polynomials, we can talk about them or distinguish them relative to the number of terms they have. For instance, 3x, it's got one term. What do we call a one-term polynomial?
Monomial.
Monomial or monomial, take your choice. Depending on which side of the Mason-Dixon line you're from. So, monomial, take your choice. Hey, you got 2 terms, we call it
binomial.
Absolutely. And this guy we're going to see a lot of, it's
Trinomial.
And once again, I don't tell you this just to give you something else to know, but because your text and your problems will refer to binomial factor or the perfect trinomial square, so you need to know what these guys are that we're talking about. Typically, after that, you got 4 terms, it's called a polynomial with 4 terms. 5 terms, a polynomial with 5 terms. Until you get to a polynomial of 10 to 19 terms, which you will only encounter rarely. Get to a polynomial of 10 to 19 terms, it's called a really bigonomial. What? A real bigonomial. You don't encounter those guys often. Polynomial of 20 or more terms, you don't get to those unless you're like in calculus 12 or something. Polynomial of 20 or more terms is called a gigantic, huge number. By the way, do not look for these under dictionary.com or in the back of your textbook. Or do not mention them to the math lab people upstairs. I don't think they're privy to this information. All right. But these are the guys you're going to be seeing referred to often, monomials, binomials, and trinomials. So I can I can distinguish polynomials based on the number of terms. I can also distinguish polynomials based on their degree. Now, that's a new term for some of you, the degree of a polynomial. So let's get a definition. Yeah, that's a pretty straightforward definition. It's just the largest exponent in any term. So as I look at that 4-termed polynomial, can you tell what its degree is? It's 3. That's the largest exponent. Let's see, I got a 3, I got a 2, I got a 1, I got a 0. 3 is the largest exponent. So we say this is a polynomial of degree 3, or a 3rd degree polynomial. Take your choice. The degree is 3. That's not too bad. Hey, what if I have more than one variable present? And we're going to have polynomials with more than one variable, with a's and b's, or with x's and y's. So how do you find the degree, or talk about the degree of a polynomial if you have, let's say, a's and b's in it? Something like this guy right here. That's what I mean by a polynomial of more than one variable. Still a polynomial. It's got terms, obvious parts. But how do you talk about the degree of this guy? Well, the definition says the largest sum of exponents in any term. So what's the sum of the exponents for this first term? 4. 2 plus 2 is 4, right? What's the sum of the exponents here?
3.
3. Did you notice, did you add that invisible one there? And the sum of the exponents here?
3.
And the sum of the exponents here?
2.
So I got a 4, 3, 3, 2, right? For the sum of the exponents. So, the degree of this polynomial is going to be what?
4.
4. It's the largest sum. It's this guy right here. The degree that is. So that's not too bad. So you just add up the exponents in every term, add up the exponents in the next term, the next term, the next term, and then see which term has the largest sum of exponents. That's not hard enough. Oh, I did it. How about that? What's the degree of this guy? 4. Once again, the degree is. All right? So just how we talk about polynomials in terms of the number of terms they have, or in terms of their degree. All right, with that in mind, let's get to the meat and potatoes of this section, which is the 4 basic operations. We're going to be adding, subtracting, multiplying, actually 3 of the 4 basic operations. We're going to be adding, subtracting, and multiplying polynomials. We'll get to division of polynomials a little bit later. But let's add, subtract, and multiply these guys. And let's go ahead and look at some of the problems from your textbook. If you got a textbook, that's fine.